Here's a very interesting piece. 450 kilohertz, the antenna match tuner.
Actually, we're dealing with two devices because I'm gonna represent you two of them on this video.
I don't have anything like to show, but I'm gonna use the fork. Why not? Okay. So we have the common phase and impedance measurement. VP, the common, and DC bias. ER, kilohertz power in.
J3 connector is only for the safety switches. The input is kilohertz power in. I don't believe it's a high voltage.
I'm gonna put it like that.
And we're going right now to the part of the connection.
I feel very much uncomfortable using the fork for it. Hold on. Now I have a bigger fork. The lab is a little bit too far away, so I'm just trying to... Okay, fine. So we have a choke in here. It's connected to two wires, and these two wires go to this box, and this box is basically RF measurement box, common, phase, and impedance. Now the connectors, the tiny connectors for the measurement purposes, or the automatic VP voltage, common and DC bias are exposed. They have a capacitors connectors in here, and the wire, okay, so the wire goes to this board, and it is this connector. It's not really choke, it's just a sensor, the SWR measurement, that's what I see. Then the wire goes up here. We have this is a little bit bigger in diameter. There is something inside of that, I don't know for sure, but this wire goes to the toroid. From the toroid goes to the terminal. From the terminal goes to this and this coil, which I thought previously is a transformer. Oh boy, it's not my cup of tea, that music, but I can dance on it anyhow. Now from that it goes to that coil. From that coil, in series connected to that coil. From that coil is connected to supposedly capacitor, from capacitor to the ground. Also from the same input wire we have this through the same terminal. In parallel we have this coil connected to this post, this coil, from that connected to this capacitor, and then connected to the board. In the board we have another wire in here, some of the circuitry here. All of this is Teflon and high quality material. It goes to the output, and we have an interesting part in the output, which is this is the wire going to the output, and the wire going to the output connector, right, this one. Okay, lower electrode. But now we have a bridge here, so I'm trying to put, okay, this is a bridge here, and this bridge is bridging to another coil. This coil goes to the doorknobs. Oh boy, not able to see it. Doorknobs going down to the ground. The Teflon coil and another toroid transformer. The high voltage BNC. The board is being called DC power relay PCB in it. It is rather like a sensor and a high voltage block. Strange, the DC power relay with the regular wire connected to the high voltage block, says danger, and then we have two wires with the regular 12 volt cheap connectors connected. It's supposed to be output, and the PC board doesn't look like it's a high voltage PC board. So something was really done on purpose, which I don't understand. And we have a fancy multicolor device which says TP1, 2, 3, 4 and whatsoever, and then 24 volts. Let me put it this way. Okay, 24 volts ground plus volt was that. I don't know if it's a kind of safety device. The transopter, I call it, European way, optical separator. Is it? Let me see what is the model number of it. Maybe the camera is able to see that. I think there is high voltage in here, two connector plates and another plate in here. Looks like a custom-made capacitor. Three objects with three legs. It looks like a rectifier for me. The grids for the bridge rectifier, and for some reason in here on this board when it says high voltage, yeah, it says high voltage. You have two tiny screws, cheap wire, which is not the best quality we could expect from this kind of device. It was probably about, I assume, $40,000 when it was new.
And I have paid for it $35, shipping free.
Fine. And the high voltage connector that goes on this side, toroid, and then it goes to the output. So kind of mystery. And this connector goes back here, right? So basically the role of this is kind of very much primitive logic. Not controller or the reader. I don't even know how to name it. I thought previously that this is a kind of clutch.
Actuator micropositioner.
It's just a shot.
Tegal is the name known from Indonesia, but it looks like it is made in California.
Oh yeah, I got it.
Look at the craftsmanship, the beauty of design.
The output, this is the output. This is the motor power for the motors and controllers interface. This is the motor. Oh boy. That's a pretty much scientific tool that I'm using right now. The fork of my wife. And Dick and John take a stand on it. Wow. We have a coil connected in series. We don't have the eddy current flowing as we have a gap in here, and even if we don't go close, we cannot really close the pot. Right. Very fast.
We're playing with Q. Permeability of air is 1, permeability of ferrites say 2000, and we have one coil on two sections on each one of the leg of the C shape. The gap is never closed completely, so I have a question how the eddy current is behaving in this situation, as we have a presence of heavy fan for cooling. One of the sort of transformers or coils with the magnetic flux regulated is either sloppy done, but it does have an offset as you see right now in the picture. Question why?
So this is the second one, and it has the same concept. You have a fan, the enclosure, two motors, DC motors of 24 volts with the gearing. This gearing is capable of moving two structures inside. We have a coil. This is a in, but it says megahertz in, so I assume it's 13 megahertz and change. And then the coil, bang of the door number knobs, another coil, a B-filler. It doesn't look like B-filler, it's not a B-filler, it's just the choke, or the device that it's allowing to measure the SWR. And then we have the output here. I don't understand. It says kilohertz in, RF out, and what was in here? Megahertz in? Oh boy. What is it? Modulator? I don't know. I thought it's just a transmatch. Okay. Daj bliżej. Jeszcze bliżej. Bliżej, bliżej. Jeszcze bliżej. I'm trying to show how that stuff is made. Okay, so we see a plate on the shaft. Okay, this is how it's done. Very interesting structure. And another question that arises: why did they put this kind of... This is definitely a coil, so we don't have a problem with that. And the coil has only a few winds. But then this structure in one coil, sorry, this is my wire from, okay now. And then again, doorknobs, capacitors. There's nothing here, just a coil and a Teflon former. If this is kilohertz in and this is RF out, then why we have on this side megahertz in? This P1 again, in the previous one it was safety feature for that was for the micro switches. Now in here I don't see any micro switches, but I see the box, closed box, and two wires coming out of it. So this is what we have.